A door is hanging from two hinges, which we've labeled A and B, and we're asked to find the force exerted on each hinge, including magnitude and direction. To solve this problem, we will need to balance forces and torques because this is a statics problem. Our door has this geometry here. It is 4 meters tall and 2 meters wide, and 3 forces act on it. The force from hinge A, which acts 0.5 meters from the top, the force from hinge B, which acts 0.5 meters from the bottom, and gravity acts on the door at its center of mass, which is located 1 meter from either side and 2 meters from the top and bottom. First, we will balance the forces in the y direction. This means that we will take Newton's second law and set that equal to 0. The 3 forces acting in the y direction are the y component of the force on hinge A, the y component of the force on hinge B, and gravity. Moving gravity to the other side and noting that the y components of the force on hinge A is equal to the y component of the force on hinge B, we can simplify and then solve for the y component of the forces on hinge A and B and see that they are equal to 50 newtons. Next, we balance the torques. First, let's put the pivot at hinge A. So the force from hinge A now produces 0 torque because it is acting at the pivot. Therefore, the only 2 forces that produce torques are the force at hinge B and gravity, as we've written here. We can write the torque due to the force on hinge B as the perpendicular component of FB times the distance it is from the pivot. In this case, the distance from the pivot is 3 meters, and the perpendicular component is the x component of the force at hinge B. We can write the torque produced by gravity as mg times the lever arm. This is the 1 meter away from the pivot, the perpendicular distance that gravity acts away from the pivot. Solving this equation here then for the x component of FB and evaluating, we see that the magnitude of the x component of the force acting at hinge B is 33.3 newtons. We then repeat this process, this time placing the pivot at hinge B, and everything here is exactly similar to what we just did, so we see that the x component of the force at hinge A is also equal to 33.3 newtons. Now that we know the x and y components of the force acting at hinge A and the force acting at hinge B, we can find the magnitude and the direction of each force. We find the direction using inverse tangent and find that the force at hinge A acts in a direction of 123.7 degrees, and the force at hinge B acts in a direction of 56.3 degrees. The magnitude of both forces is the same, which we found using the Pythagorean theorem, and is equal to 60 newtons.